And the floor is yours, Travis.
All right. Thanks, Sebastian. Yeah, my name is Travis Smith. I'm here to talk to you about the TeensyROM interface and fast load and emulation cartridge for the 64 and 128. The background story is the same I hear from many of us. A youngster started using the PET, then VIC-20, then C64. But once I moved out of the house, I left that behind to pursue a career in high tech, and finally got retired a couple years ago and got back into it. And now I'm kind of trying to combine those two past histories into one. What it is, I'll talk about in quite a bit here. But why did I make it? I wanted to do an open source project for one to kind of give back to the community that is uh, ever sharing these types of things. And I didn't see any cartridges based on the Teensy 4.1 and wanted to take advantage of its uh, high processing speed and external interfaces. And there's a large library of support to make development go quite a bit faster. Started as an experiment just to do ROM emulation and got that going, and realized I could keep going from there. This is what it looks like. The expansion port connector on the back here. There's two USB connectors to connect upstream to a computer or downstream or vice versa to a USB keyboard, for example, and a RJ45 jack for Ethernet and an SD card slot. So the features here are the basics are does ROM emulation, so all the generic single ROMs as well as multi-ROM games. Uh, Ben Squibb has done a great job of putting the one load collection together, which is a great way to enjoy these kinds of cartridges. And the fast load capability, there's a little bit of a demo here. Takes about 2 seconds to load a 48K program. It actually takes a little longer to decompress after it's loaded than it does to load it itself. And you can load programs from a micro SD card, a USB thumb drive, and there's also about 60 programs that come built into the flash. There's a SID player that uh, adjusts the tempo based on the machine type and the SID requirement itself, and a picture viewer that'll view koala multicolor as well as standard high-res pictures as well. So what you see there is real-time loading and displaying pictures. The MIDI interfaces, I should say, emulate the standard MIDI historical devices. Um, the two methods are connecting through USB A and USB B types. So with the A type, you can connect a USB MIDI keyboard and play software such as SynthCart and Station 64, and there's a few others out there. You can also use your C64 to play out into your sound-capable device if you want to do something like that. The USB-B connection connect to a computer where you can stream out MIDI files or use a sequencer to stream out MIDI information ultimately to your SID chip. Or you can use programs such as DeepSID, or website that is, to use the ACID MIDI protocol, which may not be familiar with. It embeds SID data into the MIDI stream. And there's one program out there called Station 64 that can actually interpret that data and play it back. So you can actually stream SID files over the internet through your computer into your C64. The Ethernet interface simulates a SwiftLink cartridge with a modem connected. There's AT commands to set up the Ethernet settings. So you can do the standard telnet type of BBS connections there's still several of those out and about. You can set your C64 system time. You can sync that to the internet. If you don't like the hardwired, there's Ethernet to Wi-Fi bridges out there you can use if you would rather go wireless. There's a text-based web browser feature that I'm pretty proud of. It can filter complex sites into text, so it is text-based only for the most part. There's a search engine link in there so you can do internet searches. There's a custom HTML tag to display Petsky type graphic characters, which is what you're seeing on the right here is my demo web page, which has a Petsky graphics built into that. When you download something from HTML, it'll download it directly to the USB or SD card. So you don't have to wait for the bottleneck of the 64 itself to do downloads. And then you can launch those files right from the browser. There's a bookmark feature, so you can, when you find websites that you enjoy, you can save those, and those get saved in the local EEPROM. And there's also a site browsing queue, so you can go back to previously visited sites fairly quickly. There's a couple alternate interfaces developed. This one is developed by William Pereira that runs on a desktop system, and you can fully control your C64 from a desktop computer. So you can immediately launch games, SIDs, or any other programs remotely by looking at the SD and USB drive and launch those. It's got some search features so you can quickly find things in some of the large collections that are out there these days. You can flag favorites and quickly go back to those. There's a pretty cool SID playback capability from there that keeps track of time through the database. So you can do sequential SID playback, playlist type of thing. And there's a pretty cool random feature where you can play random SIDs. Since there's about 50,000 SIDs out there, it's kind of nice to just hear them randomly, and you never know what you're going to hear there. You can transfer files from your desktop to the SD or USB card with a drag and drop feature that has recursive functionality to take full directories and subdirectories of files in one swath. He's incorporated a lot of great meta data from the high voltage sync collection, the deep SID and OneLoad64. So you can see it in the screen chapters over here. This SID view shows you, if assuming it's available, the composer and information about them. And for games from the OneLoad64 collection, shows you splash screens, etc. as a preview. We recently introduced a NFC launch system. Start that going here. This was a co-development between myself and Ben Squibb, also known as StatMat of OneLoad64 fame. He knew about the TAP2 project, which kind of pioneered this methodology. And we actually share a lot of hardware with that project. We support some of the same scanners. There's 3D case designs that are compatible to both, and the NFC tags themselves have a graphics interface so you can quickly print your own tags. So it kind of gives the physicality of old school cartridge loading with the fast loading times of modern computers. Next. Okay. Okay, a little on the technical side here. The prototyping started in December of 2022 in this rat's nest you can see on the upper right here. But that was enough to get me going to do emulation and know that if I laid out a PCB, it would work. So the first board was taped out a little over a year ago. The core architecture has remained the same since then. So the software compatibility has remained the same. The slight board changes have just been cosmetic and to accommodate 3D printed cases, etc. The hardware design was taking makers and hobbyists into account so that hopefully people feel inclined to build one themselves. It does have SMT packages, but they're the larger types, so 805s and SOICs that are a little easier to solder than some of the real fine pitch stuff. Two-sided SMT to keep the board size to a minimum. And there's a BOM published with links to DigiKey for all the parts. You can do a big shopping cart and buy all the parts at once. And it takes about an hour to assemble and test one. Block diagram. So the Teensy has an ARM Cortex processor in it, a 32-bit processor that it's all 3.3 volt levels. So most of the external logic is just voltage translation between that 3.3 volt and the 5 volt of the C64 128. It's mostly straight through level translation, just a little bit of extra logic here for the read-write line, but other than that, it's mostly a software-defined architecture, which makes it fairly flexible in that aspect. On the software side, the Teensy is all C and C++ code. It all compiles in the Arduino environment, or I should say Arduino and TeensyDuino is the add-on for Arduino to enable some of the features of it as well. All publicly available libraries. So it's fairly straightforward to compile and modify. Excuse me again. The expansion port timing control is probably the trickier part of the implementation. Basically, there's a high priority hardware interrupt that triggers on every rising edge of the V2 clock. So about once every microsecond, a hardware interrupt is triggered, and that starts a timer to know when to read or write key signals to execute reads or writes to and from the 64. So because it's an 816 megahertz core in the Teensy, I get almost 1 nanosecond of granularity, which is a pretty good timing control for that interface. So it spends anywhere from 150 to 900 nanoseconds within that routine out of every microsecond or so. 150 is if the transaction, it takes about that long to determine that the transaction is not for the Teensy and can go about its business, up to about 500 nanoseconds for a standard read or write, and up to 900 nanoseconds if it's a full VIC cycle emulation, which there's only a few games out there that actually require that, but it is supported and emulated. IO handlers are done via a common struct definition with pointers to each one that get indexed and pointed to depending on which handlers are needed. Those structs define entry points for specific routines to handle depending on what's required, an IO 1 or 2 transaction, a standard read-write, etc. And then there's also a polling functionality for background types of tasks. Teensy memory was a bit interesting to try to manage. This map on the side shows that there's basically 3 memory types of memory segments. There's 2 RAM segments of 512K each and 1 large flash of 8 megabytes. Not to scale here, of course, but it gives you the general idea. The tricky part is that only the RAM has a fast enough latency to do that ROM emulation. I can't emulate directly out of flash because the 400 nanosecond access time that it takes is just a little bit too slow for emulation there. So whenever I'm emulating something, that gets copied into both the RAM banks in the case of a very large multi-chip emulation. And then in the flash itself, we can force execution to happen right out of flash for lower priority routines. But then normal, faster execution times can be achieved by having that code reside and executing right out of RAM. The firmware can be updated, it can be self-updated, I should say. You can copy the hex file right to the SD or USB card and have it execute and self-update the flash. There are a couple of pads available for external RAM or flash on the Teensy itself, but those have that same QSPI interface that the local flash has, so I haven't found a good need or use for that yet. On the C64 side, it was all done in 6510 assembly using the Acme compiler. It's currently a little less than 5K in size. The way it works is it boots emulating a standard single chip 8K ROM. And the first thing it does is copy that information down to the 6,000 range of RAM inside of the C64 and passes execution to that, and then disappears or vanishes the original ROM. So it's not taking up that chunk of memory anymore. That's to allow for self-modification code and also to stay out of the way of most SIDs when they're playing. For most of the time, the C64 code is the master in that it makes requests to the Teensy when something is needed, and that's done through a common register set defined in the IO1 space. There's about 32 registers defined, depending on what's needed, whether it's to go execute a program, start or stop a SID, etc. And of course, that definition is shared in both the assembly code and the C code so that they're both speaking the same language, so to speak. And then the register, the fast load capability is done by a single register. The C64 code reads that register repeatedly, the same location, and the Teensy side is fast enough to know that that read has happened, updates the value so that the next read that happens in the next clock cycle can read that same location and get the next value. So it makes the fast load fairly quick in that aspect. So although most of the tasks are originated from the C64 side, there is an interrupt driven from the Teensy side for Teensy initiated actions, most of which is the remote launch capability used by those remote interfaces that I talked about previously. There's quite the list of potential improvements or additions in the future. The USB host interface gives lots of options for, been talking about Bluetooth interface or adding a printer to that, or a keyboard or mouse. There's lots of other types of files that I'd like to support. There's some improvements that can be made on the SID player and browser, et cetera, et cetera. And I'm also keeping a list of potential hardware improvements. I don't know when I'll get to a future design. I'll probably wait for the next generation of microcontroller to look at this, but this would give us some other new and nifty capabilities. So here's a list of links. You can find all the documentation, design files, source code, firmware releases, and the 3D printed case files are all on the GitHub site. There's a great Discord server with lots of like-minded folks talking about the TeensyROM that gotten some great input from there. I try to do a demo video anytime a new feature is added, and there's a big playlist available there. And if you're not up for building your own, I sell them myself out of the Tindy shop, and there's a couple other shops out there that sell pre-assembled and tested units as well. So thank you to these people and a whole lot more who have helped and contributed and given ideas for this project. Something I certainly could have I couldn't have done alone. So I certainly appreciate that. That's about it. Questions?
Yeah, many thanks. Time for questions, I guess.
I want one.
I can say, yeah.
Yeah, I think it's incredible. It's something I've been thinking about a long time, that it should be out there, but it's there now. So brilliant.
It's a particular feature catch your eye, or?
Well, I mean, I don't want to drive too technical, but how does it sort of suspend the CPU running and while it replaces stuff in the working memory, or how would you?
No, it actually doesn't do true DMAs. I've been able to do this all without a true DMA functionality, although that's something I would like to look at in the future. But no, the transfer, the fast transfer capability is all done through that single register read I spoke about shortly earlier, and that the assembly code reads one register, one IO space register over and over, and copies that into the local RAM. So it's able to get basically 1 byte every microsecond by reading that over and over. And of course, the CRT emulation itself is done by emulating a ROM, so there's no actual transfer to RAM needed. It's all emulating an external ROM as like a ROM cartridge would.
All right. Sweet.
I see a comment from William Pereira. Amazing work, Travis. So I guess it's the same William Pereira that you're
It is.
probability
I will.
would be good. I have a couple of questions as well. So it comes back with a few software there. So you've been showing the browser, these things. How can one maintain this one? So, for example, if there is a bug somewhere in one of the software that comes with it, how do you is it all from your GitHub, or do I need to take one thing here, one thing there? How does that work? Do you have like
Everything is available on the GitHub. So when you install the Arduino environment and the Teensy, it's called TeensyDuino environment, which is a layer on top of Arduino, that gets you 99% of everything. There's one library just added recently for the NFC capability that you do have to download to support the scanner, the NFC scanner. But other than that, all the libraries come standard with the Arduino environment. There's a build page I created in the GitHub that shows how to, or where to find all those utilities and how to install and build it yourself if you want to do it that way. That's the Arduino side. If you want to compile the assembly side, of course, you'd have to download the Acme compiler and run a batch file to do that if you want to get into that low level of detail. But most things can be, most people who want to tweak the code themselves are able to do things in the Arduino level on the Teensy side.
Okay. Yeah, good that you mentioned a website as well from to purchase it from Europe, because it was my first, when I saw ships from USA, then usually it gets at least in Belgium, most probably it will get taken by the customs, and then
yeah, I see those. I get a lot of orders from Europe, especially since Ben Squibb's been involved in that last project. It's become pretty popular over there, and when I send them out, I see the landing costs of all of them, and I know I've actually talked to a couple people over there about potentially building them and selling them locally. So hopefully it'll bring the shipping costs down. So.
Yeah. Good. And then you have good plans for the future. You plan to do all these things by yourself, or are you welcoming? I don't know.
Yeah, I definitely welcome feedback and input. The first truly collaborative was the NFC capability, in which I worked with Ben on some of the low-level stuff. William has done the user interface pretty much on his own with some feedback from others, and I get lots of feedback as far as ideas, and I certainly welcome code input, but so far it's been mostly me doing the actual coding itself, which is fine. But yeah, there's GitHub supports pull requests and the whole methodology. I'm certainly open to that.
Okay. I see a question on Facebook from Gerster, actually. He's asking if the cartridge will work on the Amiga 65.
That's a good question. I believe so. There's been a lot of compatibility testing, but I don't have my list in front of me right now. But basically, as long as the expander port is running at the same timing, I know it's been tested on many of the newer, FPGA-based types of C64 emulators. So as long as it has a expansion port that's compatible with the C64, it should. And I'm I hate to say it definitively, but I'm pretty sure that the 65 has been tested as well.
Maybe that's a mission for Gerster. That's your way to contribute, Gerster. You can buy one and then you can try and provide feedback.
Yeah, I appreciate all feedback.
Good. Any more questions from the attendees? Apparently not. So many thanks, Travis.
Thank you.
Recording now.